Hello friends, Dr. Patterson again. In this video, I am going to go through Lab 1, but instead of programming in MATLAB, I'm going to program in Arduino C. And so instead of the lab tests, which I'll go over in the MATLAB versions, we'll be using a lot of the functionality built into uh, the Arduino, or sorry, the language for Arduino and the Arduino IDE that supports it, and essentially just using a lot of their generic setup to construct the programs that we want to tackle the lab tasks with. So the reference page is, you can look up Arduino reference or documentation, and you'll find all these functions, which some of them should sound fairly familiar. The ones that we'll look at, we did read digital pin and write digital pin in MATLAB. Instead, we'll actually be looking at digital read and digital write. And so let me just open both of those actually. So digital write, you're sending a pin value, which is either an integer or a byte, and then you're setting a specific value. In this case, a high or low signal, which will be a 1 or a 0. True or false statement, just like in MATLAB. And then the digital read will be saying digital read and specifying the pin. And then you get back a value that's between, I believe for standard Arduino is 0 to 1023, which we will need to interpret in a way that we did in a similar, or no, digital read. Sorry, thinking about analog read. Digital read, you'll get 0 or 1, just like in MATLAB. So forget what I just said. So those are the two main functions that we use. We'll have to structure the code a little differently because we can't do everything that we did in MATLAB, nor should we, because MATLAB requires that the board is connected to MATLAB and communicates that way. For programming in C, you're actually compiling the program, and that is sent to or programmed onto the Arduino. And so you'll be running it straight from the board. And if you wanted to, you could even unplug it and hook up a battery or external power supply and have that program continue to run. So first thing I'm going to do is plug this in. And then when we go into the Arduino IDE, we can go up to Tools, and I'm going to switch boards here. You should go to Arduino Uno, and then you go to Tools again and Port. And I was on COM3. Yours might be different, but I'm going to pick COM3. And I can just test this just by clicking the upload button. Nothing will happen in this program, but it is guaranteed to compile and then upload to the board if everything is set up correctly. So it just sent it to the board, and it is doing absolutely nothing, just like the program suggests. So let's look at the first lab task. So the first one was turn on an LED when one button is pressed, turn the LED off when the second button is pressed. And so we need to do effectively exactly what we did in MATLAB, but with programming in C. And so we want to loop over something multiple times where we read a digital pin. Specifically, I said button 2 in this MATLAB version. And if that's the case, I turn on the pin on pin 4. Otherwise, and then the next one is I read from pin 3. And if pin 3 has a high signal or the button is pressed, then I turn off the LED. So if we were to go over to Arduino C, the first thing we need to do, we can just test that we know how to turn the LED on and turn it off, right? So if you want to do that, it's that digital write command. So digital write, and we can specify a pin. And so if I said digital write and I specified the pin 4, I don't have to say D4 because it's a digital pins. And so it actually goes straight to the digital pins there. And then I want to specify a value. I can say 1. And then at the end, I have to place a semicolon to tell it that it's the end of the line. In the setup, I can't just tell it later during this main loop, which this loop is very different than what you get in MATLAB. This automatically loops over and over and over. As soon as all the lines of code have run, it goes back to the start of the loop and goes through again. So this while loop that we had in MATLAB, the while 1 is greater than 0, this is taken care of for us with this void loop. This is a function that is called over and over and over again when your program is uploaded to the Arduino board. In the setup function, we have to tell it that we're going to use pin 4 specifically for output. And so what we're going to do is go over the documentation and down at the, oh man, they don't have it. Oh, they do have pin mode. Let's look up pin mode real quick though. And then we'll go. So the pin mode, you have to, like I said, you have to tell it what to do. So pin mode, you specify a pin and then the mode. And it can be set to input, output, or input pull-up, which means that when it's set to input mode, it also enables a pull-up resistor on there. And so it's instead of I had pull down resistors. So I could have used the internal pull up resistor to get very specific logic on the button presses. But what we can do this time is just say, I want the pin 4 to be an output because I'm going to be writing a signal, a 0 or a 1 to that specific pin, and I want it to turn on or off. And so I'm going to go back to the Arduino IDE, and I'm going to say pin mode and specify the pin. It'd be pin 4, and then also specify that I want output, and then a semicolon at the end again. And if I wanted to, instead of hard coding the value of 4 in there, I could say int LED pin. In MATLAB, we rarely have to specify a variable type, but in C, you have to use variable types. It's just the way that the language is structured. You have to be much more explicit about the variable types that you use and how you set them up in the first place. Whereas MATLAB, you can just on the fly add new variables in. It's much more complicated to attempt to do that in C. So what we're going to do is say LED pin is equal, not 3, equal to 4. And then I can change out, instead of those 4s, I can put in LED pin. And so now when it loops, it's going to turn that on. I know this is going to work. Let's do it. So pin 4 will turn. You have to save it first. Let me save it. Just navigating to my 1301 folder. We'll say task 1. And you can see in the lower right, it's uploading. So that LED turned on, right? Nothing fancy. If we wanted to turn it off, we could say, not pause, that's MATLAB, delay. And then we're telling it in the number of milliseconds how long to delay. So let's say we wanted to, for 200 milliseconds, stay on. And then I'm going to turn it off. And so I'm going to send a 0 signal or set it to a state of 0 or false, and then delay a little bit. And so now it should blink on and off. So if we send that, and so now I have that LED blinking by itself. And I can unplug this. This is one of the things that's different from MATLAB. I can unplug this. And whenever I plug this back in, as soon as that board powers up, I'm going to see that same behavior because that program, which was compiled on your computer, was then essentially put into the memory for the board. And so whenever it turns on, it's going to run that program again. So we have that blinking LED. Now, if we go back to our MATLAB code, we want to read a button value. And so we need to specify a new pin. Let's say int, we'll say button 1 was on 2. And then we might as well throw in another button 2 is on pin 3. And we need to set the pin modes for those as well because we want to have those as input. Oops. And so now for button 1, I've said I'm going to use this pin as input. And then down here, let's write an if statement. So why don't I just have it blink if the button is being pressed? So if digital read, and I can specify which pin, which would be button 1. And that's going to come back as a 0 or 1, a true or a false statement. And the way that I've wired up the button, when I press it, it's going to be a true signal, a 1 that's read by the Arduino. And so when the button is pressed, and with C, you have to have curly braces that start and end essentially all the inside of the if statement. You can do a single next line, right? Let's see. Yes. You can, but it's easy to mix it up, right? So I just for the sake of making sure that I don't have any strange errors, if I want to clean code up later and possibly remove any curly braces around single statements within an if statement, then I might do that. But really, this is especially for starting out like you might be, this is a safer way to do it. So when that button is pressed, it will now blink. Otherwise, it will just be in an off state. So let's upload that code. So nothing's on. And then I'm going to press this button and it's going to start blinking. Now, when I let go, the delays are in there. And so it might actually keep blinking for a small amount of time. It might stay on for a fraction of a second. But it largely works much faster than what my code in MATLAB did. And so now we're able to use the if statement, we're able to read from that button. And so we can throw in a second button press. Really, we wanted to turn that LED on if one button is pressed and turn it off if the other one is pressed. And so this is all we need in that first if statement, just turn that pin on. So why don't we end that one? And then we can say if digital read, then we can read button 2. And then in that statement, we can just have the LED turn off. And so now when we upload this program, when I press one button, it turns on. When I press the other one, it turns off. Just like we had in MATLAB, except the response on this one is much faster than what you see in MATLAB, because there's no communication between the computer and your board. It's all running on the board. And so the amount of time, let's say, gosh, forget how many cycles it takes to do an analog or digital read. I think it's 4, and it's running at 16 megahertz. So in theory, I think if you do it efficiently, you can read an input pin on the order of megahertz. Um, we're not we're not doing it as efficiently as possible, even though this is very simple. The digital read and digital write commands in themselves are essentially like convenience functions. If we wanted to, we'd have to write in something called assembly, which could essentially be like as fast as you could possibly do. But we're using these convenience functions like digital read, digital write. Even the loop function is kind of like a convenience one. You don't have to have it in there to run code on the board. It's just something like a simple construct that, or simple way to approach program creation using these types of boards. So really, like, there's very little delay in between each line of code that's being run. And in the MATLAB version, every one of these commands was information being sent from the computer to the board and potentially data being sent back as well. And the communication over a serial port for a board like this is actually fairly slow. And so that's why we see much faster response. Part of why we see much faster response when we're just compiling it and running it on the board directly is we don't have to worry about any of that communication. And those lines of code don't require any additional steps on the board. It's just this is effectively what's being done on the board, and it doesn't have to worry about anything else. So that was a very long version of task 1. Now we can look at task 2, which was turn on the LED one at a time by incrementing or decrementing which LED is addressed, and you should be able to stop and have a change direction. Okay, and so what we had with task 2 is I kind of used some complex or mildly complex math. I tied a single value to both the increment and the amount of time to delay. Could we do something similar? We could. Why don't we stick with the same idea just to see what that's going to look like in C versus MATLAB. So what we can do is come back and let's do a new. Oh, give me a second while I get it perfectly lined up. All right, so what I'm doing is I'm just saving the program. Oh, that's right, task 2. Looked like there's a space. And we need those 2 pins again, or the 2 buttons. We also need all of the LEDs. So let's, without getting into arrays, let's do this the ugly way. Let's say LED 1 is 4, and then we can go up from there. And LED 2 is equal to 5. LED 3, 6. Almost there. Okay, we have all of our LEDs. There are much better ways to do this. We're not there yet though. So we can start with those individual LEDs. We also need the buttons. So we'll say int, we'll give it a little space and say int button 1 is equal to 2, and int button 2 is equal to 3. And those are the pins that we're going to use. And then inside the setup, we need to set pin modes for all those, not pane mode. It's one of my fluids lectures, pane mode. We set the LED pin. We want those to be output. And I'm gonna, because we have a lot of these to put in. All those LEDs as output. And then we need to do the button as input. And do the other button as input as well. And so now we have all the LEDs that we need for output and the 2 buttons as input. And in theory, that's all that we need for setup. I'm going to specify a variable out here that is a float, which is like a decimal point number. It's represented by 4 bytes. We can say that this is going to start as 1.0. And then down in the loop, the first thing that we did was that we checked if a button is pressed. So if, let's look at the MATLAB code again, right? So if the one button is pressed, you change the increment to this. If the other one is pressed, we change it to another value. So let's go back and say if digital read, and then pass it button 1, and we can do that, and then we can do an else if digital, and see it's separated else if digital read and button 2. And then inside there, just like we did before, we can set what the increment values are. So increment is equal to 1.0. Increment is equal to negative 0.5. And right now, nothing's really happening, but I'm just gonna, if you go up, it doesn't have the fancy stuff where MATLAB will like immediately show you where there's errors. So we can click on verify. Oh, what did I do? F. Oh. Never gave it a name. Like pulling other languages. So C# and Java require that you put F at the end for floating point. So we've got this and it compiles okay. It hasn't uploaded to the board, but if we press those buttons, in theory, it will go to value 1 or the value of 0.5. The way we could test this is if we wanted to write to the serial port, which we're not even going to do right now. We're just going to trust that these values are right, and we'll be able to tell by maybe just blinking. Let's blink a single LED. So what we can do is go back up here and say, I'm going to capture a previous time. And if you were to grab the time, it doesn't come back as a floating point number like what you have in MATLAB with tick and talk. You can either use a function called millis, which let's pull up the documentation. Millis. There's millis and also micros. So millis gives you the total number of milliseconds since the program started. And micros gives you the total number of microseconds since the program started. So we're gonna just look at millis, and we're gonna look, we have to essentially like keep track of the previous time just like we did before. And so I'm going to say for this one, along a previous time. I think we can even get away with an integer on this. I think it might time out after 32 seconds, but we'll be okay with that for now. We'll say previous time is equal to 0. So an integer, literally, you're just having integer values, and these are in microseconds. And then we will also initialize current time. Yeah, we'll say 0. And then in here, we can say if, how do we want to do this? We need to use the time increment. And so we can use the same math, but we have to convert it to millis, right? So if previous time plus, we have to say 1,000 times, what would be floor? Do they have floor? They've got round, I know that. Where is it? Huh. Well, I think we can just cast it as an integer. This complicates it though. Really, there's no round. Power min max constraint. What we're gonna do is cast it. Let me think about this. I don't want to make this too complicated for you guys. I don't know if this is gonna work. Let's, instead of the increments, that's a float. Can we get away with it being the time delay? Oh, is there a sine function? That's too complicated too. So let's go with an integer increment. So 1 or -1. And then we'll add a second variable in there. I didn't want to do this, but LED delay, we'll call it 1,000. We'll start with that. And then in here, we'll say LED is 1,000. So that's a 1 second delay. And then in here, we'll say LED delay is 500. So it's half a second delay. So when it's decrementing down, it'll go twice as fast as when it's incrementing upwards. So we can then say instead is previous time plus LED delay less than millis, which is the total time elapsed since the program began in milliseconds. And then in here, we can grab the previous time, new previous time is equal to millis, just like we did before. And then we can use the same logic if we need a variable LED pin. That's what we did before. We used LED pin, and so then we were able to check to see if it's 4 and if the increment is less than 0, or if it's 9 and it's greater than 0, do nothing. Otherwise, turn the LED pin off. and then choose a new one and turn it on. So we're going to keep that entire logic structure the same. So let's go down here and say if, or better yet, we need an integer LED pin. We'll start with 4. And that's the current LED pin. Yeah, these sadly are only getting used for the setup, but we'll go with it. So if LED pin equals 4 and the increment is less than 0, or the LED pin is equal to 9 and increment is greater than 0, and we need parentheses around that entire thing, and we can have our curly braces, and then so that's if we want nothing to happen. You could say do nothing. Different way of commenting / twice. Else, oops, curly braces again. And then in here we can say digital write, and we can tell it LED pin because we don't have to add on D in front of it like we did with MATLAB and this line. And then we can say turn that LED pin off. And then we want to increment that LED pin, just like we did here. Before we were using the floor function, we don't have to do that because we have an integer-based increment up or down. So we can say LED pin is equal to LED pin plus increment, and then LED pin, and do the same. I'm going to do the same structure here. Exactly the same. And then we're going to write that new pin to a high value. Think it's going to work? I'm skeptical. Let's verify. See how many errors we have. None. Unheard of. All right, let's click upload and see what happens. It's working. Let's press the down here. Oh, the other one. It worked. So same exact logic structure, probably not the best logic structure, I agree, but it's what I set up in the first place. And so really it's just translating from one programming language to another with this different setup where we have to worry about a setup. That's one of the things that MATLAB takes care of for us, is setting up the pin modes based on the functions that are included. And then the loop structure, or the loop function in this case, automatically loops back over that program. And then the nice thing is when I unplug this thing and then power it again in some other way, whether it's USB or something else, I can still have that same program run. I don't have to reprogram it. The last one, what I'm going to show you instead of playing the sound is something that can help you debug your code. Instead of playing the sound, I'm going to have it print statements to the serial port. And we're going to look at, with the Arduino, how we can read values off of there and see what it's doing. So give me a second and I'll pull up another Arduino page. All right, so I've just created a new program, and we're going to set it up in a very similar ways to what we did before, because really it's just if I press one button, I'm going to have it print a statement to the serial port, which is essentially like if I go back over to this code, I can look at what is being received by the board or from the board by the computer. And so I can open up a serial monitor and actually read everything that the board is sending to the computer. You can see my program still running over here from the last one. So if we close this out, we'll be back to that. So we can say integer button 1 is equal to 2, integer button 2 is equal to 3. Come down here and set our pin modes. Let's say B1 is input, and same thing for the other one. And then come down to the loop, and really, if I press one button, I want it to do one thing. If I press another button, I want it to do another. So I can say if digital read and say button 1, then I'll do one thing. If digital read button 2, I'll do the other thing. And what that thing is going to be in this case, instead of playing the gong sound or the handle music in MATLAB, I'm just going to have it print a text that says play gong or play handle. And what I can do is open the serial port. I'm going to say serial, and the serial port is essentially like a bunch of code that's automatically included in any of your Arduino programs, so you can easily communicate over the serial port. So we can say serial.begin and then specify the rate at which we want to communicate with the computer. I believe the standard is 9600 baud, which is 9600 bits per second. So super slow. But we'll do it, even though that's super slow. Still faster than the phone or the computer modems that I had when I was a kid. So we can say serial.begin 9600, and then down here inside that first button, I want to say serial.print line, println, and then I'm going to have it say play gong sound. And then inside the other button, I'm going to have it say serial.println and play handle music. Right, so super simple. Just like if we went to task 3, it was just those 2 if statements inside a loop. And that's all we have. We have a loop with 2 if statements, and then inside those if statements, slightly different actions. So if let's verify, worked. So then we can upload this one. And when I press these buttons, right now, nothing's happening, right? But if I click on this little magnifying glass right here, the serial monitor, and then we try that again, whenever that button is held down, it's going to play that gong sound or play handle music. Now, what if I only wanted it? The one interesting thing this points out is it's registering the button that's being like continuously pressed, and it's going so fast, the code is, that if I hold it for a second, I get hundreds of these statements, or not hundreds, but dozens. So what we can do is say, I want to monitor that button. Let's read the value, and then if the value is true and it's not the previous value, then we'll print that. And so what I'm getting at is if the button is pressed and it wasn't previously pressed, then we actually want to play it. We don't want to continuously play it while someone holds it down. Then we'd have like 100 overlapping sound waves all being played at the same time if we were in MATLAB still. So we can say, let's set up, let's stick with integers for now. We can say integer previous button 1 is equal to 0, and integer previous button 2 is equal to 0. And down here, at the very end, we can say previous button 1 is equal to, this is again imperfect in how we're setting it up, because in theory I could release the button in between these two being red, but this will be accurate enough for what we're attempting to do. So I'm grabbing, at the end of the loop, I'm grabbing what the previous button was. And then I can say that again, previous button 2 is equal to digital read for B2. Now I have the previous button value. And so if I can say if digital read and not, or that's the correct not in this language, PB1 and not PB2, then we want it when the button is pressed, but not previously pressed. And so if I continue to hold it down, then it'll grab that new previous button press value and it won't continue to print that out. So let's try this and see if my logic is sound. Most of the time it's not. Let's clear output. So I'm gonna press and hold it. And it only went once. And I'm gonna let go, nothing. Press it again. Yeah, we're getting some weird inconsistent behavior. So it's happening more than I thought it would, or not correctly having that combination of logic there. So what we can do is say, we can grab the value initially. We'll say int current button 1 is equal to this. And then we can say current button 1. If current button 1 is pressed and previous button was not, and we down here we can say current button 1. And so instead of reading it on two separate occasions, which was causing it to only register some presses, now we're only reading it once and we're saving that into a variable, and then we're setting that to the previous value for the next time through. And we can do the same thing for the other one. We can say integer current button press 2 or current button 2. No one will ever accuse me of being a good variable name person. So if you're cringing right now because of my variable names, I am not surprised. So let's try this one. Now that we're down to just one read for each pin. Oh, gotta open the serial monitor. There we go. So each time I press it, it's printing it once and only once. And every time I press it, it's showing up. And then the other one, same thing. Checks out. Those are the 3 lab tasks in C. Next up, assuming I have time to continue doing this, I'll be using a slightly different board, which will allow me to program with Python. But it's same form factor, and so all the wiring will effectively be identical. We'll have to switch up the pin numbers, but then you'll be able to see how that comes together in Python instead. So that's all I've got for this one. See you in the next video.